and then definite integrals. Yesterday, we have solved one problem of definite integrals, that is integration of 0 to 1 log 1 plus x by 1 plus x square into dx, very important for 7 marks. Okay, so now today we will continue with one of most important problem of definite integrals, and we will move to differential equations, and we will choose the most important problems once again. Okay, so anyhow, from the first day, what we have taught you, okay, till our last class, you please practice. Okay, and I'm sure, I'm expecting whatever I have taught to you, that will appear in exams. Okay, you tally my words, today's what the words I'm telling to you, and your question paper that will come to you in your hand in just within 15 days. Okay, so anyhow, all the best, and let's start today's class. Okay, it is definite integral, most important problem. You please practice. Definite integrals, most important problem. Evaluate integration of 0 to pi x sine cube x divided by 1 plus cos square x into dx. Okay, very, very important problem. Okay, what is given to us is, see here, evaluate to obtain 0 to pi x sine cube x divided by 1 plus x square into dx. Okay, this complete solution is a lengthy solution. See here how I'm solving it. Okay, so the first step, as usual, I said you, and follow this in your exams, that is solution. Given that what is given to you, I is equal to 0 to pi x sine cube x sine cube x divided by 1 plus cos square x into dx. Okay, this is given to us. First, I'm applying King rules to particular this integration values. What is that? Look at here. Yesterday also I have written, for example, if you are having 0 to a f of x into dx, you can write integration or integral 0 to a f of a minus x into dx. Okay, so here just I'm applying that King's rule to a particular function given to us. Let's see what we are getting. So the first thing, integration of 0 to pi, wherever we are having x, just apply King's rule, pi minus x sine cube pi minus x divided by 1 plus cos square pi minus x into dx. Okay, just the first thing, first step, this is the solution. Now look at sine 180 minus theta. What is sine 180 minus theta? sine 180 degree minus theta is equal to sine theta plus sine theta. Okay. And here cos of 180 minus theta. Okay. Cos of 180 degree minus theta is equal to cos of minus theta. We know that cos of minus theta is again cos theta only. Okay. So now see here the basic trigonometric conversions I have to apply here. So according to that, what I'm getting, integration of 0 to pi minus x into sine cube, sine 180 minus theta is sine theta, that is sine x, sine cube x, divided by 1 plus cos 180 minus theta is cos of minus theta, but cos of minus theta is again cos theta. So just directly you can write cos square x into dx. Okay. This we have got, and this is nothing but I. Next, look at here. Just I'm multiplying these terms with this. Okay. So what I'm getting, I is equal to 0 to pi into sine cube x dx, pi into sine cube x dx, the first term. This is cube, pi sine cube x into dx, divided by 1 plus cos square x, 1 plus cos square x into dx. Next term, minus x into sine cube x divided by 1 plus cos square x. Just separating the terms with the multiplication and writing the denominator separately for each term. So now this is minus integration of 0 to pi x sine cube x divided by 1 plus cos square x into dx. Okay. See here, this is the value of I. This complete integration 0 to pi x sine cube x divided by 1 plus cos square x into dx is the value of I you can observe here in the first step. So instead of writing this complete term, I can write I and this become minus I. Okay. So I can write I is equal to 0 to pi sine cube x divided by 1 plus cos square x into dx minus I. When this minus I comes here, it becomes plus I plus I is 2I is equal to 0 to pi sine cube x divided by 1 plus cos square x dx. Okay. This pi is a constant. You can keep it out, not an issue. And this 2 becomes here in multiplication comes here. So you will get I is equal to pi by 2. This is outside and this becomes comes here. 0 to pi sine cube x divided by 1 plus cos square x dx. Okay. This particular term sine cube x, I can write sine square x into sine x. Okay. So this you can write as is equal to pi by 2 integration of 0 to pi sine square x into sine x divided by 1 plus cos square x into dx. Okay. This we can write. So now this particular sine square x, see here, we know that sin square theta plus cos square theta is equal to 1. So I can write sin square theta is equal to 1 minus cos square theta. Okay. So on the place of this sin square x, with the help of that conversion, I can write 1 minus cos square x. Okay. So this I can write as, here I'm writing, this is I is equal to pi by 2, 0 to pi sin square x. I can write 1 minus cos square x, 1 minus cos square x divided by 1 plus cos square x, 1 plus cos square x into sin x dx. See how I have written the entire term. I is equal to pi by 2 integration 0 to 1, 0 to pi, 1 minus cos square x divided by 1 plus cos square x into sin x dx. Okay. So now, in order to simplify this particular term, okay, I have to take some assumptions. Okay, some what I can say, I'm taking this as some equating to some variables. Okay, so I can write, let t is equal to cos x. Okay, so now differentiate with respect to x. So you will get dt is equal to d by dx of cos x is minus sin x into dt. Here, sorry, dx into dx. Okay, this minus I'm writing with this. Okay, this is multiplication, comes here in division, just writing that here numerator. So minus dt is equal to sin x dx. So this sin x dx now become minus dt for us. Okay. One important work is completed. Now we are having two limits, lower limit and upper limit. How to convert that? Look at here. LU means lower, LL means lower limit. Okay. UL means upper limit. So here at x is equal to 0, lower limit is x is equal to 0. So what I can write here, t is equal to cos 0 degree. On the place of x, write 0, 0. Cos 0 is 1. We know that cos 0 is 1. So our lower limit is now become 1. So instead of writing 0, we have to write 1. Okay. So now next, upper limit. Okay. Coming to the upper limit at x is equal to pi. So t is equal to cos x, that is cos pi. Cos 180, we know that it is minus 1. Okay, so we have got lower limit as well as upper limit values. Okay, so just write it. Okay, now we have to substitute all the values what we have converted just now in the given I. Okay, function. That is, I can write I is equal to pi by 2. Lower limit is, what is lower limit? 1. And what is upper limit? Minus 1. The first important work. And then 1 minus cos square x, that is 1 minus t square, because cos x is t, so cos square x is t square. So this is 1 minus t square by 1 plus t square. Okay, sin x into dx is minus dt. Just writing in the bracket minus dt. Okay, this minus sign I'm taking out and writing with this pi by 2. Okay, so this is minus pi by 2 integration 1 to minus 1, 1 minus t square by 1 plus t square into dt. Okay, look at carefully. In this particular term, I am taking minus common. What I'm taking? Minus common. So minus pi by 2 integration 1 to minus 1. If I take minus common from in the numerator, it becomes t square minus 1 divided by, you can write 1 plus t square or t square plus 1, not an issue. Okay, so 1 plus t square into dt. Now, this minus into minus plus, so it becomes pi by 2 integration 1 to minus 1. Okay, this is 1 and this is minus 1. Okay, minus into minus plus over. See here, t square. This minus 1 I am writing as plus 1 minus 2. Okay, just you need to practice these steps, taking minus common and writing this minus 1 as plus 1 minus 2. Okay, divided by 1 plus t square into dt. So what, see here, I'm separating denominator with respect to numerator in just writing, splitting the terms, writing separately. So t square plus 1 if you write, or if you write 1 plus t square, not an issue, both are same. So it becomes pi by 2 integration 1 to minus 1. Take a big bracket because this pi by 2 for the whole function. Integration of 1 to minus 1, 1 plus t square by 1 plus t square into dt minus 2. Take it out, 1 by 1 plus t square into dt. Close the bracket. Okay. So now this is get cancel. Okay. Just writing here. Okay. So what we are getting is equal to pi by 2 integration 1 to minus 1 in a bracket integration of 1 to minus 1 1 into dt. Okay, minus 2 into integration 1 to minus 1 1 by 1 plus t square. Okay, into dt. So see here, integration of 1 into dt is t. We know that integration of 1 by 1 plus x square is tan inverse of x. Okay, here I am writing integration of 1 by 1 plus x square into dx is equal to tan inverse of x plus c. Okay, just I'm using that formula here. So what I apply integration to the given functions. So 1 into dt is just t. So t, lower limit, upper limit. Okay, minus 2 as it is. This becomes tan inverse of t. Okay, lower limit, upper limit, and close this big brackets. Brackets are very, very important. So now apply the limits. What we are getting? Pi by 2. Okay, upper limit minus lower limit. Upper limit is minus 1 on the place of t, then minus lower limit, that is 1. Okay, minus 2, tan inverse of minus 1, upper limit, tan inverse of minus 1 minus tan inverse of 1. Okay, we know that this is minus pi by 4 and this is pi by 4. Tan 45 degree is 1. Okay, either it may be inverse is minus 1. Okay, so just writing that. So this I can write pi by 2 minus 2. Minus 1 is minus 2. Minus, take this also in bracket. So minus 2, and then this is minus pi by 4, and again minus pi by 4. Okay. So what is this? This is pi by 2 minus 2 minus 2 into minus 2 pi by 4. Okay. This 2 1 the 2 to the get cancel, and again these two and these two get cancel. Minus into minus become plus. So you can write this as pi by 2 minus 2 minus into minus plus pi. Okay. Therefore, finally I can write I is equal to pi by 2 into pi minus 2. Therefore, integration of 0 to pi x sine cube x divided by 1 plus, what is that? 1 plus cos square x. 1 plus cos square x into dx is equal to pi by 2 into pi minus 2. Okay, this is the solution. So now what the else to inform you is that here how was we have started this problem. Just we have taken I is equal to 0 to pi x sine cube x divided by 1 plus cos square x into dx. Okay, that is just a half line, 1 by 4th line. Question is 1 by 4th line. But when it's come to the solution, it is a lengthy and big solution. So observe each and every step. Okay, how we are converting that particular function into, how we are splitting the terms, how we are converting, when to take common, when to change the denominator. Okay, so these all things you will come to know only by practice. Okay, so understand this all terms, particularly the conversions, and when to take the minus. Okay, common as common. Observe each and every terms and practice it. Okay, and then we will move to the our next chapter, that is the last chapter of to be differential equations. Okay, just observe this. Now I'm going to rub this. So we will move to the our next chapter, that is differential equations. Okay, so now we will go to the next, that is differential equation. We will solve the most and most important problem of differential equations. A very important problem. I'm expecting this time it should come in the 4 marks. One LAQ from differential equation, one SAQ and one VSAQs. Okay, so let's see how to solve what is differential equation, integrating factor, homogeneous differential equation, non-homogeneous differential equation, soluble for X, what is the order of differential equation, what is the degree of differential equation. These all things we have completed. Okay, now we are focused only on important and very important problems. So what I'm going to solve is one of the most important problem. So start with this. This is the problem. Solve sine inverse of dy by dx is equal to x plus y. Okay. Yes, this is the problem given to us. We have to solve it. Okay. Solve sine inverse of dy by dx is equal to x plus y. How to solve? See here, the first step, solution. Given that, what is given to us? Sine inverse of dy by dx is equal to x plus y. Okay. Now I can write dy by dx is equal to x plus y. Okay. Dy by dx is equal to x plus y. Just I have sent this inverse to that side. Okay. Then it becomes what? It becomes like this. Sine of x plus y. Okay. This is the first change. This inverse comes here and it takes this form. Okay. Dy by dx, now it becomes sine of x plus y. If you want to make it this as equation 1, not an issue. Now, from here, just I am assuming let x plus y is equal to t. Okay. What I'm assuming, this x plus y is equal to t. So what I'm getting, look at here, differentiate with respect to x. Okay. So we know that d by dx of x is 1 plus d by dx of y is dy by dx is equal to dt by dx. Okay. Now this plus 1 comes here, it becomes minus. So dy by dx is equal to dt by dx minus 1. Okay. Finally, we have got dy by dx as dt by dx minus 1. Okay. Now from equation 1, instead of writing dy by dx, I can write dt by dx minus 1. And on the place of x plus y, I can write t. Okay. So now look at here. This I can write dt by dx minus 1 is equal to, on the place of dy by dx I'm writing, here just I'm writing now from equation 1. Now from equation 1. Okay. dt by dx minus 1 on the place of dy by dx sine x plus y is t. Okay. Sine t. So this I can write as dt by dx is equal to 1 plus sine t. What I can write? 1 plus sine t. Okay. This minus 1 comes, it becomes plus 1. So 1 plus sine t. Okay. So now just I'm interchanging the positions, writing in this form 1 by 1 plus sine t into dt is equal to dx. Okay. Just I have took this term. See, this term is in, I can write like this into 1 also. Then it comes in division here. Okay. So now apply integration on both sides. Apply integration on both sides. So what we are getting? Integration of 1 by 1 plus sine t into dt is equal to 1 into dx. Okay, 1 into dx. We know that 1 into dx is x plus c. To get this simplification form, it's very easy. Coming to here, in order to simplify this particular, just I'm rationalizing denominator here. Okay, 1 plus sine t. Rationalizing denominator, so it becomes 1 by 1 plus sine t into 1 minus sine t by 1 minus sine t, okay, into dt is equal to integration of 1 into dx is x plus c. Okay, so write it properly. So what I'm getting, integration of 1 minus sine t divided by 1 minus sin square t dt is equal to x plus c. Okay. Again, the basic use of trigonometric identity, writing here. Sin square theta plus cos square theta is equal to 1. So cos square theta is equal to 1 minus sin square theta. Okay. This conversion I'm using here. So let's see what I'm getting. 1 minus sin t by 1 minus sin square t. This 1 minus sin square t, I can write cos square t. Okay. So this is integration of 1 minus sin t by cos square t into dt is equal to x plus c, is equal to x plus c. Now separate the terms with respect to numerator, write the denominator. So integration of 1 by cos square t into dt minus integration of sin t by cos square t. I'm writing cos t into 1 by cos t into dt as it is. Just cos square t I'm writing in this form. Remaining everything is same. So 1 by cos is nothing but secant square t into dt minus sin t by cos t is tan t, and 1 by cos t is secant t. So I can use that. So I will get here tan t into secant t into dt. Okay. Now we know that integration of secant square x is tan x. So this I can write RHS x plus c, here also x plus c. Okay. Okay. So integration of secant square x is tan x, that is tan t minus integration of secant x into tan x, or tan x into secant x is secant x, that is secant t is equal to x plus c. So on the place of t, I can write x plus y here. Therefore, tan of x plus y minus secant of x plus y is equal to x plus c is the required solution of the given differential equation. Given differential equation. So in order to solve this complete, we need to get first all the formulas of integration, differentiation, substitution concept. Once we perfectly know all the formulas, then we can represent the each solution perfectly. Okay, very important. Look at from the beginning, observe each and every step and solve it. Okay, it's depend on up to your practice, how you're practicing. Okay, check it once again. Then we will go to the next problem. I'm reading your comments. If I have doubt, please ask. This is asking for 7 marks only, and sometimes 4 marks. But maximum time it is comes in LAQs, that is 7 marks. Okay. So now we are going to solve a new problem of same differential equation. Okay. कमेंट से तो बोलिए. A new problem. Solve dy by dx is equal to xy plus y divided by xy plus x. Okay. See here, there are different categories problems. One of the category is this. Solve dy by dx is equal to xy plus y divided by xy plus x. Okay. How to solve? Look at the solution. Solution. Given that what is given to us? Dy by dx is equal to xy plus y divided by xy plus x. Okay. So from this numerator, take y common. Okay. So dy by dx is equal to, if you take y common, you will get x plus 1, or you can write 1 plus x. Okay. If you want to write 1 plus x or x plus 1, not an issue. And from the denominator, what you will get common? X. So again, you will get 1 plus y. Okay. These things we have got. So just now, just I'm interchanging terms with respect to their derivatives. Okay. So what I'm getting here, if I interchange 1 plus y by y into dy is equal to 1 plus x by x okay, into dx. Okay, interchange the derivative, respective derivatives. Okay, now apply integration on both sides. Apply integration on both sides. Okay, so what we are getting, integration of 1 plus y by y into dy is equal to integration of 1 plus x by x into dx. Okay, now separate the term with respect to numerator. Okay, so I can write integration of 1 by y into dy plus y by y is 1. So it is integration of y by y into dy is equal to integration of 1 by x into dx plus integration of x by x into dx. So this y get cancelled, x get cancelled. So we know that integration of 1 by x is log x. So similarly, integration of 1 by y into dy is log y. So you can write log y plus integration of 1 into dy is y is equal to integration of 1 by x is log x plus 1 by 1 into dx is x. This I am writing constant log c in order to simplify this complete. Okay. So now here I'm taking these terms to this side. Okay. And sending these to that. So what I'm getting, y minus x is equal to log x. See, log a plus log b, I can write log ab. So similarly, it becomes log cx. Log a plus log b, I can write log ab, basic law of logarithm. Okay. And this becomes, comes here, it becomes minus log y. Okay. So again, log a minus log b, I can write log of a by b, basic law of logarithm. So therefore, y minus x is equal to log of cx by y is the required solution. Okay. So check it, the problem from again from the beginning. All the 7 marks questions are little bit lengthy, but some 7 marks problems are short. And this is for 4 marks. Okay. Check this problem from the beginning. Okay.